Hello everyone. So today we will be solving LeetCode 1846. It's called the maximum element after decreasing and rearranging. This is also today's problem of the day. So we will be looking at it. So we are given an array of positive integers and we need to perform some operations, possibly none, on our given array so that it satisfies these conditions. The first condition is that the value of first element must be 1. So the array's zeroth index element should always be 1. And the second is the absolute difference between any two adjacent elements must be less than equal to 1. That means any two adjacent elements, suppose I and j, are adjacent elements, so they should not differ by a value that is greater than 1. So also there are two types of operations that we can perform any number of times. Our first operation is decrease the value of any element of array to a smaller positive integer. So in one operation, we can decrease value of any element and make it a smaller positive integer. And in operation 2, we can rearrange the elements in whatever way we want. So these are the two operations available. And using these two operations, we need to make the array in such a way that it satisfies both of these conditions. And we need to return the maximum possible value of an element in an array in the array after performing the operations to satisfy the conditions. So first we need to satisfy these conditions, the above two, using these two operations. And after doing that, we need to return what's the maximum possible value of the element in the R array. So I have also shown you two examples. Suppose we have ARR is something like 2, 2, 1, 2, and 1. So suppose we perform the second operation, operation 2. So operation 2 says rearrange the elements of array to be in any order. Suppose we rearranged it like 1, 2, 2, 2, 1. Suppose we rearrange the array like this. Now let's just compute the adjacent differences. Let me index it 0, 1, 2, 3, 4. So the adjacent, we would check every pair. So this is the pair. So difference is 2 minus 1. That is the after one minus the previous element. 2 minus 1 is 1, which is, and also we would take absolute of it because it's given in question, right? Absolute difference. Absolute of 1 is also 1. And this one, as you can see in the given condition, is less than equal to 1. 1 is less than equal to 1, which is true. So this pair is fine. Now we move to the next pair, that is this one. So here the difference is the next element minus the previous one. So it's 2 minus 2, which is 0. Again, it's less than equal to 1. So again, this pair is also fine. So our condition isn't violated yet. So next, we go to the next pair. It's again 2 minus 2, which is 0, which is less than equal to 1. So it's fine. Then we go to here, last pair. So it's 2 comma 1, right? So difference would be the second one minus the first one. So it's 1 minus 2, which is minus 1. But we also need to take absolute. So absolute of minus 1 is 1, which is again less than equal to 1. So this pair is also fine. So you will notice that we made the array in such a way that all the conditions, that is these two, are satisfying using these two operations. We just perform the operation 2 in this case, in this example, as we just rearrange the array. So, and then we simply what we needed to return, we needed to return the maximum possible value. And you can see in this array, the maximum possible value is nothing but 2. So we returned 2 as the output. So this is how we did that. Now let's move to the second example. Before that, let me erase the content. So coming to the second example. So here array is 100, comma 1, comma 1000. Suppose we check this pair. This is the difference is 1 minus 100, which is minus 99. Taking absolute would give 99, which is not less than equal to 1. So this, the first pair itself violates the condition. So we need to rearrange it. So suppose we did something like we rearranged it into 100 and 1000 by performing the operation 2. Now we will also perform operation 1 in this case because still the difference is not less than equal to 1 in both the pairs. So what we do is we would make this 100 2 by decreasing it and performing the operation 1, and also this 1000 to 3. Now our array becomes 1, 2, and 3. Now as you can see, all the conditions are satisfying. The difference here is 1, and here also the difference is 3 minus 2, that is 1, which is less than equal to 1. So now since all the conditions are satisfying, we just return the maximum element, which is 3. So 3 becomes our output. So I hope the question is clear and you are clear what we are trying to do in this. So let's head over to the approach. Also, one more thing, the final rearranged array, we got this right. So we will also check that the first element should be 1, like our first condition. This should also satisfy. Had it not been 1, we would have returned false, even though the absolute differences were less than equal to 1. But had it not been 1, the first element, then still we would, make more modifications. We could not stop there. So both these conditions should satisfy. So coming to the approach, I have taken the second example. So what, what if we had array size equal to 1? Suppose we have only one element in our array. Suppose our array is 3, just one element. So in this case, see, we already know that we need to make our array in such a way that first element is 1 and adjacent elements differ by at most 1, right? So since in case of the array length being 1, we will only have one element, so no point of checking the adjacent elements. We just need to make sure the first element is 1 or not. So in every time we see array length equal to 1, we just need to make the the single array element equal to 1. That's it. And since the array length is 1, that is, it only has one element, so maximum also will be 1. So if our array length is 1, we would do nothing but just return 1 because maximum number would be 1 only. Or if it was not even 1, like here it was 3, but still we needed to make it 1 because of our first condition, which says first element after rearranging or applying operations must always be 1. That's why we made 3 to 1 and then computed the maximum, and maximum was 1. So in case of one length array, output would simply be 1. So this was the edge case we would be writing. Coming to the generalized case. So what if we sort this array? Sorting gives 1,000. Let me index it. So after sorting, what we can do, also we could, after sorting, we would do array 0 equal to 1. Since anyways, we want our first element to be 1 only. It can't be anything else. So after sorting, what we will do, we would just run a loop from I equal to 1. See, I equal to 0 we have already handled. So I equal to 1 to array dot length I plus plus. and we would check for every pair the difference. Array of I, suppose you have these elements. It's 1, 2, 3, 4, for example. So if array of I, that is the second I'm talking about. Suppose I is this, then I minus 1 becomes this. So if array of I is array of I minus 1 plus 1. See, if array of I means this, and I minus 1 means just the previous one. So if the array of I1, that is this one, is greater than the previous one plus 1. The previous one is 1 and plus 1 is 2. So it can be at most true. If it's greater than that, that means the difference condition is violating. Then we need to fix our current ith character. What I'm saying is, suppose the condition was opposite. Array I is this. Suppose, so running on it in this case on this, I minus 1th is 1 and I is 2. So I array of I is 2 greater than array of I minus 1, which is 1 plus 1, which is 5. 2 is greater than 2, which is false. So when it's false, that means we don't need to adjust anything. Our difference condition, that is the absolute difference condition, is fulfilling and it's not violating. So if it's false, like if it's the else case, we would do nothing. So since we are doing nothing, you can skip the else case entirely. But if this condition wasn't met, that means suppose here instead of 2, we would have suppose we had 5. Then I becomes 5 and I minus 1 is 1. So now putting this condition, so array of I is 5 minus array greater than array of I minus 1. I minus 1 is still 1 plus 1. 5 is greater than 2, which is true. So that means our difference condition now got violated and we need to do some fix. So this was the purpose of this if. So if this if executes successfully, that is if it's true, that means our difference condition is violating. To fix that, what we will do is we would just simply make the current element, that is the ith element, equal to array of I minus 1 plus 1. Why we did so? Because suppose we had 1, 5. This is I minus 1, this is I. See, what we want? We want maximum absolute difference can be 1. It can be 0 or 1. So maximum absolute difference can be 0 or either 1. So in this case, the absolute difference is 4. So to fix it and make it in such a way that it becomes 0 or 1 only, we can either change this 5 to 1. If we would have done that, we would get the absolute difference is 1 minus 1, which is 0, which is correct. Or we would have gone with swapping this with 2. So now the difference is 2 minus 1, which is 1, which is still correct because it's less than equal to 1. 0 is also less than equal to 1, 1 is also less than equal to 1. But we chose to replace it with I minus 1 plus 1 and not the same as the previous one, like we did here, because at the end, what do you want? You want to maximize our maximum value, right? So that's why we are assigning array I to array I minus 1 plus 1 and not just this previous one. Both will satisfy the absolute difference condition because 0 is also less than equal to 1, 1 is also less than equal to 1. But to maximize our maximum element, we need to write this as we want the difference to be 1. It's simply saying that difference can be 0 or 1 both, but we would make difference 1 because it will increment our maximum value every time. So we would maximize our maximum value and that would be our correct output. So I hope it's clear. Now let me also code it. Acha, before coding, I would also tell you why I sorted. So in this case, we did something like 100 and 1000 first, right? And then we changed this 100 to 2 and this 1000 to 3. And we saw that absolute differences are less than equal to 1 and first element is also 1. That means our conditions are satisfied. And we returned our maximum value, that is 3, as our output. So this is correct. Or we could have also made this 100 to 2 or this 1000 to 3 here only. 2, 1, 3. Or not even 2. You would have made it something like 1 and this 1 to 2. So we would have got 1, 1 and 2. And still you can see this absolute difference is 1 minus 1, which is 0, which is less than equal to 1, fine. And here also it's 2 minus 1 equal to 1, which is less than equal to 1. So absolute differences conditions are satisfied. And the second condition is also satisfied that first element should be 1. So we would have done it this way too. But still we chose to sort. See, we are not anywhere given in the question that we need to perform. We need to make the necessary array, the required array in minimum number of operations. Minimum of operations is not given as such in this question. So that's why I went with sorting, because what sorting does is, see, what sorting does is it's put the lower numbers, smaller numbers first. So the smaller ones appear first and then followed by the larger ones. So in our question, we have decrement option is available, but increment option is not available. So we cannot, increase a smaller number to a larger number, but we can do the opposite. So that's why so that means the smaller numbers are more restrictive because they can't be increased. So they need to be dealt with first. So that's why we deal the smaller numbers firstly, and that's why we place them, prior to the larger numbers, because larger numbers can be dealt at a later stage by performing the decrement operation. So this was the reason for sorting. Now let's head over to the code of it. So coming to the code, we need to return the maximum element, and we are given an array called ARR. So we first compute the length of it. As discussed, if length is 1, we directly return 1. Then we sort our array, and we also set the first element to 1 because we must do it. It's given in the question. Then first element is dealt with. So now we deal with the remaining elements, that is 1 till the n minus 1th element. We check if the difference is exceeding 1. So we need to fix our current element. So we fix it by assigning a value which is equal to previous element's value plus 1. And we could have also done just the previous element, but as discussed earlier, we want to maximize our maximum element. That's why we also did plus 1, because both of these are same. In this, absolute difference is 0, and in this case, absolute difference is 1, and both are uh, you know valid in this case because both are less than equal to 1. At the end, see, since we have sorted our array, so in a sorted array, the largest element is also always the last elements. So that's why I returned at the end array of n minus 1, that is the last element. Because in sorted array, last element is the largest element. So this was our approach. Coming to the time and space complexity. Since we are sorting, time complexity is n log n, and we didn't take any additional space, so space complexity is constant. So this is the time and space complexity of this question. So I hope the question is clear, and thank you so much for watching.